which would you prefer? The complete and total isolation of the South Pole telescope, or the complete and total isolation of your apartment, except that your apartment is near a bunch of people who could get you sick, but you do have your wife there?
Oh man, that's a. So is that can we negotiate the terms here?
Well, what would be, maybe this is a hypothetical, so sure, let's negotiate. Hello and welcome to Bad Astra. Today we are interviewing John Hood. John is a PhD candidate at Vanderbilt University working remotely at the University of Chicago. He's an experimental cosmologist working with the South Pole Telescope, or SPT group, on the development and testing of polarization-sensitive antennae for the CMB S4 experiment. Hi, John. Thanks for interviewing with us today.
Hi, Astra. Thanks for having me.
Can you tell me, what is cosmology?
So, in one sentence, cosmology is the branch of astronomy that basically focuses on the study of the origin and evolution of the universe from the time of the Big Bang all the way up until today. And some even branch out and study what is going to happen in the future with our universe as well.
So it's like the big picture.
Yeah. So while observational astronomy and other types of astronomy focus on like specific things like galaxies, galaxy clusters, planets, and all of the things in between there, cosmology is wondering how did all of that come to be in the first place? And we study the structure and origin of the universe that leads to all of those things coming to be.
So I know that at the SPT, you study the cosmic microwave background. So what is the cosmic microwave background exactly?
So the cosmic microwave background is the remnants, the hot remnants left over from the Big Bang. And it's essentially been known as like the smoking gun to the Big Bang theory being true. So what it actually is if you look at a picture, a lot of times what you'll see is this kind of blotchy green, yellowish, orange circle. And that's the cosmic microwave background. And what you're actually seeing are these tiny little fluctuations of heat across the entire sky that we see in microwave wavelengths.
Could you explain the Big Bang Theory in under 5 minutes and explain it to me as though I'm a 5-year-old?
Explaining it to a 5-year-old, how would I explain the Big Bang Theory? I would say that imagine you're in a dark room with nothing else inside of it.
Where's
But
my mommy?
in the your mommy's in the hallway with you, and you just set up an experiment to show your mom what the Big Bang is.
Okay,
So
I have an adult nearby. That's good to know.
yeah, so you have an adult. Yeah, you have an adult nearby. You and your mommy have set up this experiment with nobody inside of this room. But since there's nobody in there, what actually is inside of that room is a balloon that you stuffed with glitter. And that balloon is sitting on top of like an air tank. And essentially what is going to happen is you're going to push a button and it's going to slowly expand that balloon. And eventually the balloon's going to pop. And now that the balloon has popped, all of that glitter is scattered around the room.
I have 2 questions.
Okay.
What color is the glitter?
Okay. So the glitter is, what's your favorite color?
It's purple.
Then the glitter is purple.
Yay! And also, how long is it going to take my mommy to get the glitter out of everything? Because last time I was in a dance show and there was glitter everywhere for about 6 months.
Yeah, so double that probably. There's probably going to be glitter discovered later on that you thought that you got up. Yeah, this, unless we use the really big chunky glitter, then maybe it'll be easier to get up.
Okay.
But that essentially is what the Big Bang is. It's believed that at one point in time there was nothing around, there was nothing in space, and all of a sudden there was this explosion. And from that explosion, all of the matter and materials that we know of, like the electrons and things of that nature, came from that explosion. So all of that is represented by the glitter that was in the balloon. But one of the weird things about it, and now I'll ignore that part. Well, yeah, so
I'm
that's
five. We can keep it.
Yeah, that's what I was like. No, never mind.
I was ready to be like, so what does the room represent? And then I was like, wait, no, that's too profound for a 5-year-old.
So that's the Big Bang.
Okay. So you work at the SPT, the South Pole Telescope. That's what's behind you. I can see it.
Yeah, this one right here.
Aside from being a telescope at the South Pole, my amazing powers of logic got me there. What is the SPT and what does it do?
So the South Pole Telescope is a microwave and sub-millimeter wavelength telescope that it's a all sky survey machine, essentially. And basically, from what you see here, so for what you can see on the telescope, there's this giant dish right here that actually catches the microwaves coming from space. And those microwaves are reflected down into thousands of detectors that we use to actually get pictures of what I was telling you earlier about those blotchy, like orange, green, and yellow patches in the sky. SPT over the years has gone through a couple of different variations where initially it was studying the polarization of those blotches. And now in SPT 3G, what it's actually looking for are like galaxy clusters. So we can actually find galaxies and all sorts of amazing things using this telescope. Another project that I'm actually working on with this telescope, we're studying active galactic nuclei, are giant black holes in space.
Yeah, so like quasars, blazars.
Exactly. Like, those are my favorites.
Yeah, they're so pretty. Oh my God.
They really are. They make some of the most beautiful astronomy pictures, in my opinion.
So, John, I know that you actually went to study at the SBT. I believe it's a little bit of an inside joke. They call it being deployed.
Yes.
So,
Yeah.
when were you deployed to the SBT?
So I left for SPT on November 7th, 2019.
2019. And when did you come back?
I never came back. Like
How
I'm
long
still
was your
there.
deployment?
It was supposed to be for about 6 weeks total, but we kind of started hearing about this COVID thing while we were there, and it was kind of like, hey, you could stay or you could go. And I was kind of like, yeah, I'm gonna stay. Like I don't want to have to deal with all of that up there.
You spent all of 2020 and a good portion of 2021 just hanging out sledding with penguins?
No penguins because they don't come this far south, but yeah, we've kind of become penguins ourselves. So yeah, in a way, we do a lot of sledding and going out on the snowmobiles. Those are a lot of fun. I learned how to do some really nice tricks on those.
That's awesome. Just to be clear, you were allowed to come back at any time. You just chose to stay at the South Pole because you thought it would be preferable to Chicago. Yeah, that's probably accurate.
Well, I wouldn't say I was able to come back at any time, but during the summer seasons, like they do ask, like, hey, you want to leave now? And then it's like you kind of ask what's going on up north. And then we found out that it's like, yeah, the lockdowns are still in effect. A vaccine's getting ready to roll out, but they haven't released anything yet. So it's like, yeah, let me know when that's done, and then we'll come back.
That's kind of fair.
As long as the work gets done, I figured nobody would care, right?
Yeah, I mean, but what about you? Like, isn't the South Pole, I don't know, freezing?
Yeah, it is, but it's really warm inside of the station. Like the station's kind of like a nice 65, 70-ish all the time, like, which is perfect for me. Like, I love it. I love that temperature. So I can hang out for a while if need be.
And do you have a good internet connection? Are you getting Netflix at the South Pole? Do
Oh
you have a good
no.
VPN?
Oh no, no, no. The internet's not the absolute best, but there's a lot of other things. Like there's like an entire room full of movies that I can watch. I've rewatched the entire Stargate series like 4 times now. I can almost quote the first season by heart.
So, are you getting out and hiking at all? I mean, I know you probably want to see Antarctica before the whole thing melts.
Yeah, so we get out and hike a little bit. Like the telescope itself is about a kilometer away from the station, so that's like a nice little walk back and forth every day. Do it a few times and you get your workout in.
Nice. Do you have any words of wisdom to share with the Northerners?
What can I say at this point now? Once the vaccine rolls out, please go get it so we can come home.
Yeah, everybody, please get vaccinated.
Like not really words of wisdom as much as a request. Like, please.
So, will you return from the South Pole to your friends and family who probably miss you a lot at this point? Once
Yeah,
there's a vaccine.
yes. Yeah, I'll return like as soon as things calm down a little bit. Like this is not a live picture because it's currently winter, so the sun has been down for a few weeks now. But as soon as the sun comes back up, if things are better up north, we'll be on the first plane out.
So, how do you feel about just being at the SPT and really kind of abandoning your fellow humans in this time of crisis?
You know, sometimes I feel bad about it, but then other times I think about it and I'm like, I got work to do. That
Mhm.
helps me kind of keep my mind off of it. It gives me a sense of I'm fulfilling a duty and I'm not just abandoning people, right? Like,
Yeah.
not like I'm just down here hanging out, watching TV and playing pool all day.
Have you
Like,
gotten good at pool?
pretty decent, pretty decent. A lot better than I was when I first got here.
Yeah, that's your pandemic hobby.
Yeah, my pandemic hobby was playing pool. There's a guy named Mikey that keeps destroying me though. I don't know how to beat him.
That was a fun little that was a fun way to leave reality for a little bit. I enjoyed that. Um,
Oh, that was good.
to clarify for everyone, John got back in, what was it, December 2019?
So I was deployed from November 7th until December 23rd of 2019. Yeah, 2019. So I came back. I actually ended up making it back just in time to be locked in my apartment for a full year. For the entirety of the pandemic, just like everyone else.
So, which would you prefer? The complete and total isolation of the South Pole telescope, or the complete and total isolation of your apartment, except that your apartment is near a bunch of people who could get you sick, but you do have your wife there?
Oh man, that's a so is that can we negotiate the terms here?
Uh, well, what would be, maybe this is a hypothetical, so sure, let's negotiate terms.
Yeah, so if my wife could get a position as a contractor and come to Pole with me, I would definitely take the isolation of South Pole.
Yeah.
Because that way we'll both be there. I wouldn't have to worry about her getting sick or anything as well. But yeah, I guess the way it is now, I would have to take the isolation of the apartment and just kind of looking at people out the window, wondering one day, one day.
Could you tell me a little bit about your research projects specifically?
Yeah, so I'm currently working on two main research projects. The first one is, like you said earlier, I'm working on doing detector development for the CMB S4 experiment. What I'm doing in particular with that is I'm testing certain materials that are used to make the microstrips that connect our antenna to the actual detectors. And what we're hoping to figure out is like which of those materials have the lowest loss of signal going from the antenna to the actual detector so that we can get the most out of our signal absorption. So that's the experimental project that I'm working on.
Mhm.
And on the analysis side, like I said a little bit ago, I'm actually working on studying AGN, or active galactic nuclei, with SPT. And what we're doing there is like what we're hoping to basically kind of show that while this telescope has primarily been used for CMB experimentation and like galaxy cluster finding and things and lensing, gravitational lensing in the past, we want to show that we can actually like do a little bit more with that and see how much information we can get from studying these AGN as well.
So you're not just in instrumentation, you're also in observation.
Yeah.
That's so cool. Get you an astronomer who can do both.
Yeah, that's one thing that I always kind of found interesting. When I was in my master's phase of graduate school, I was mainly doing observational work, but it was always the question of, I always kind of had questions like how do the detectors work that are collecting this data for me? Like I want to know like exactly what's happening from sky to telescope, from telescope to data set. And now I'm actually being able to do that. And it's an amazing experience to kind of see this is how we make the detectors to make the detections and observations that are sensitive enough to get this data to allow you to see all of these different things. So seeing it from literally the entire process has been a lot of fun.
That's awesome. So I know how your instrumentation fits in. You're building the telescopes. Um, but in terms of fitting into the overall field of cosmology, you study active galactic nuclei. What can active galactic nuclei tell us about the early universe?
That is a good question, and one that I honestly haven't really spent much time thinking about. I've been just so excited to actually learn anything that I could about them, and just like seeing that SPT could collect data in this new wavelength. Yeah, that's something I'm going to spend a little bit of time to think about now to actually figure out. One thing that we do know, in the past when people observe these like sources, these AGN, like in Blazars in particular, is that when we observe them, we tend to see if there's a flare in the optical wave bands, then we also see one in the gamma ray wave bands. So there's a correlated activity that says if one happens, the other happens. So maybe since we can now observe and we see things in the millimeter as well, maybe that can tell us a little bit more about the mechanisms that cause those flaring events to happen.
And these are two separate peaks, right? They're,
Mm-hmm.
huh.
Yeah, so there are two separate peaks, two separate ways to look at the energy distribution, to say, so to speak of these sources
I
or these
wonder,
objects.
that would be very interesting to know why there was something that peaked both in the gamma and visible spectrums. That I want to ask you why, but I know you have to check with your research project. This is why
Yeah,
I'm bad at astronomy. I need instant gratification.
so the optical and gamma ray parts have been like discussed, and there are like models, like multiple models that explain this activity and everything. But essentially, what causes the optical and gamma ray counterparts are this mechanism called synchrotron radiation. As the synchrotron radiation peaks, it accelerates photons up into the optical regimes. These particles then collide with other high energy particles that upscatter them into gamma ray regimes.
Oh, okay. So
So once we see one, we expect to see the other because of these physical mechanisms
so
going
the
on.
gamma rays are almost a product of the visible light rays.
Yeah, that's one way to think about it. Yeah. There are other like theories and like explanations for it as well, but that's the more common one, the common thread that I was tending to follow when I was initially doing this project.
That's really interesting. For quasars and blazars, do they let you keep all of the pretty pictures?
So so sadly, I haven't been able to take any actual pictures yet. I do have some snapshots of the sources, but the snapshots that I have, they're not the pretty pictures that we would expect to see, that we would typically see on like APOD or Astronomy Picture of the Day. But instead, they're essentially just dark space with a white dot in the middle. And it's like, yeah, that's my source right there. I know it's Deck. I can tell you what it is. So I guess technically I do get to keep the pretty pictures, but the pretty pictures aren't as pretty as what we're used to seeing.
You mean we don't yet have optical zoom good enough to see point sources in the
Oh
very
man.
early universe?
If that was possible, oh man, we would have so many new things. Hubble does a really good job with some of those for optical,
Yeah.
but maybe SDSS and some others as well. But we'll have to see.
Hey, job security because the people want it.
Yeah, as long if you can make pretty pictures of things in space and like explain what it is in like a nice fashion, you're pretty sold.
That was 90% of my job at the planetarium. It was like, see this pretty picture? That's what it is. That was
And
the
people love pretty pictures. Like it was actually for Valentine's Day one year.
Aw.
My wife got me a framed poster of the Chandra X-ray Observatory, like their top 20 like sources, like on a poster, like the prettiest ones. And I was like, this is dope. It's like I like this. And
You're
I
a good
had
wife.
it framed until like I accidentally broke the frame.
Aw.
But I still have the poster.
Oh, good.
Yeah, I still have the poster. That's not going anywhere.
That's a good wife you've got there.
Yeah, she is.
So, John, now that I've descended the conversation into pretty pictures, I think you can probably see that I've reached my max threshold for daily science. It happens abruptly. Let's transition into any advice you might have for maybe people who want to study astronomy, high school, early college students who are thinking about getting a PhD.
The first bit of advice that I could think to give right now is this goes for studying. I feel like this is good for whether you want to study astronomy, like physics, and like some other form of physics, biology, or what. If it's not fun, don't do it. If you find that you're having a good time and that you're enjoying what you're doing, then continue doing that, because astronomy and physics are tough subjects. But if you're actually enjoying the product of what you're doing and you're enjoying the process, it makes it that much easier to continue going down that path. This is something that I had learned really kind of early on in my academic career. And I think that is one of the things that like really helped me out the most. So it's like I know that I've always wanted to know more about space. I've always been very curious. So studying astronomy, once I figured out that it was like an actual like major, was kind of like a semi no-brainer after someone convinced me that astrophysics and astronomy were the same thing. If you find that you love that topic, that field, then just continue doing that because it makes it a lot easier.
Someone had to convince you that astronomy and astrophysics were the same thing?
Oh yes. When I started undergrad, I was in a pre-engineering program and I was set to do 2 years at Columbus State, and then I was going to transfer to Georgia Tech. At this point in time, like I grew up going through school being told I wasn't good at math, like you're good with your hands, so do something with that. So I was originally in tech school for machine tools. Once I finished that, well, I didn't even get to finish that program because they shut it down because they didn't have enough students interested in it. And the tech school at that point offered us two things. They said you can either keep your credits and continue into the new 4-year program, or you can lose all of your credits and start over in the 4-year program. Didn't really seem like two options to me. It was kind of the same thing. So I decided if I was going to go into a 4-year program, I would just transfer to the local university. So I transferred, started the engineering program, and ended up taking an astronomy course. So I was like, this is fun. I love astronomy. Why wouldn't I take an astronomy course if I could? And the professor kind of noticed that he approached me one day and he said, you kind of have a knack for this. He's like, have you ever considered like changing your major to astrophysics? And I actually laughed. Like, I didn't intend to do it. I just had like this nervous laugh, I guess, sometimes. And he said that, and I just out loud laughed. I was like, I've never even taken a physics course before. It's like, no, I'm like, I'm not gonna do astrophysics. And over the next couple of weeks, he kind of like would pull me aside on occasion again and ask me, are you sure you're really good at this? So he finally broke me, and I decided to give it a try. And he said, so how about this? Change your major, officially change your major so you can enroll in the courses. Try the courses for a semester or two. And if you don't like it, I'll submit the paperwork to change your major back to engineering. And here we are now, about 8 or 9 years later, and I'm starting the last year of my PhD in astrophysics.
That is a good professor right there.
Yeah, he's still a professor his name's Dr. Sean Cruzen, and I still contact him all the time. Like now whenever things are going crazy, like he's kind of like my ground. Like he's the person that I go to when I really need to like kind of get my head on straight. Before my master's thesis, like I was on the phone with him like 30 minutes before I actually defended. And it'll probably be the same thing for my PhD.
That's so lovely. I love that. That's just, I'm so glad I asked about that story. That, oh man, I wish everybody had a professor like that that could just be like,
Yeah.
you're
It makes a big difference when you have somebody or a group of people, because Dr. Cruzen he was a professor, but he was also the director of the Coca-Cola Space Science Center, like back in Columbus, Georgia. And everybody that's there, like all of the staff there, have been like super supportive of me on my journey, like throughout graduate school and even undergrad and everything. And they're the people who I like kind of lean on for like my academic support outside of my like wife and family.
everybody watching this, if you want to go into STEM or really any field, find a community that will tell you what to do with your life and
Yeah.
recognize that maybe you're great at astrophysics and you don't know it.
Yeah, find a good support structure. Like if you have a good support structure combined with you doing what you love in the first place, that makes it all the easier to manage.
So, John, do you have any advice for people who don't just think they're bad at math? They're truly bad at math. They don't enjoy math. It does not spark joy. But they like looking at pretty pictures. They want to know a little bit more about astronomy, about cosmology, about space. What would be your recommendations for non-physicists, non-math people to just casually learn more about astronomy and news?
For people who are non-astronomers, they don't really like the super heavy scientific side of it or things like that. There are ways that you could still contribute heavily to the astronomy community. There's a group called the AAVSO, I believe, which is the American Association of Variable Source Observations, Observers. I can't remember. I'll look it up in a
What
second.
is it?
The AAVSO.
The American Association of Variable Star Observers. Yep, you were
Yeah.
right.
So the AAVSO, the American Association of Variable Star Observers, are a group of people who they're passionate about astronomy, and they have their own telescopes. And what they do is they go out and they have their own setups, and they take pictures and they monitor variable sources in the sky on like a daily basis, and they submit that data to a database. And sometimes they can actually use that information for quick follow-ups on career astronomer telegrams. So say somebody at a major telescope like CTIO in Chile says, hey, we noticed something happening with this. There's a good chance that there's a member of this worldwide organization that was also watching that same thing. And they can say, hey, I have data for that going back like a few days, or I can watch that now if nobody else can get to it. And doing things like that are tremendously helpful to the scientific community.
I love that. So it's just kind of like a little army of amateur astronomers helping
Yeah.
out the field. I love that I love that you can be an astronomer as an amateur and still be relevant. I think that's
Yes.
so cool.
I believe that's like one of their like strong points, like one of their selling points. It's just like you said, like you love the field, but maybe you don't want to have to go to college for X number of years to get a degree so you can consider yourself official. Maybe it's more of a hobby for you, and doing it on an official level will take the fun away.
Yeah.
Like if that's the case, then yeah, you can still be a part of the community and help out in that case, because you can do those sorts of things.
So, if anyone is interested in getting involved, the mission of the AAVSO is to enable anyone, anywhere, to participate in scientific discovery through variable star astronomy. And there will be a link below if you want to get involved, if you have a telescope or if you want to buy a telescope and just start looking at stars. You too can be an astronomer. Do you have anything else you want to plug before we sign off?
Let me see. If
You've got a
you
soapbox, use it.
Yeah, if you ever find yourself in the Columbus, Georgia area, be sure to stop by the Coca-Cola Space Science Center with the mask, or once everything reopens, still with the mask, but stop by and just enjoy the exhibit. Like it's one of the few non-NASA stations to have actual NASA artifacts from the space shuttle program like in-house. And I think you'll just like really enjoy it. They have a planetarium. You can see all these like artifacts from the space program and everything there. It's amazing. That's where I spent the early stages of my career, and that's my foundation. So I have to mention them whenever I get a chance to.
And I'll put a link below if you want to go visit. If you're in the Columbus, Georgia area, or you're within driving distance, you want to go pay them a visit, I will put a link to that museum below. Thank you so much to John Hood for stopping by and talking about cosmology and his work at the South Pole Telescope with us.
Thank you for having me.
Thank you to all the viewers who made it to the end of this. I hope you enjoyed learning about cosmology, and remember to always keep an open mind. Astra out.
Ad Astra, to the stars, to the stars.